Brilliant. So, welcome everybody. I'm here to, my name is Rolf Brink. I'm from Asperitas and I'm leading the immersion workstream within the Advanced Cooling Solutions Charter. And I'm here today to present the first result and the first submission that comes from the community from the immersion track as a submission from ACS. And it covers the immersion standards. The current document title is Immersion Standards and Best Practices. The purpose of this document, the purpose of this contribution is to define standards to allow immersion technologies within OCP. And the background of this is that there is a lot of different immersion styles and immersion technologies out there in different shapes, different sizes, different liquids, different methods, different thermodynamics, different pros and cons. And the big challenge is to define some kind of a standard, some kind of a baseline that allows all these immersion technologies to evolve. This industry is still in its earliest stages. So a lot of developments are still happening. There's a lot of new insights still being gained, new inventions being made to allow very high efficiency with liquid. There are some incredible advancements in this part of the industry. So currently it's one of the most dynamic parts of cooling. And it's sometimes very spectacular as well. So it's very interesting to be involved in this. But the challenge is to be inclusive to as much as possible without putting up roadblocks that are way too big. So the contribution, this document of standards is generated by the community. So the current contributors to this document are here on the screen. So that's Jessica Gulbrand from Intel, sitting here in the room as well. Nigel Gore from Isotope, sitting here as well. John Bean, I think he's not present, right? Okay. And Rick Payne from Plex, and obviously myself. Is Rick Payne in the room, by the way? No? Okay. Now, the intention of the workstream, which has been discussed in the ACS Charter, is to make this, to use this not so much as a set of recommendations, but as an actual minimum requirements document, minimum requirements level. And therefore it's fairly basic in nature, but it is an unprecedented document in a way that nobody's ever managed to create some kind of a baseline for immersion technology. And the first thing that we're addressing is to define the different types of technologies that are out there. You've just seen Alibaba with a great solution that they've spent many years on developing. And they've done a terrific job. They're doing a lot of things right, if not all the things. But it's categorized as one of the flavors of immersion. So first of all, the liquids are divided between hydrocarbons and fluorocarbons. Hydrocarbons are oils, whether they're synthetic or based on mineral oils. And fluorocarbons are used in single or dual phase situations. They're highly engineered. And the characteristics of the different fluids are very relevant when it comes to solution design and also to adopting a certain technology for a certain goal. So these design considerations are described to a basic level in this document. Now we'll be getting very deep into this matter this afternoon, so make sure to be here at around at 3:30, I believe, for an in-depth session about this, because I will be going into a lot of details on what this all means and what type of influence that will have. But also the immersion styles are radically different. So the Alibaba solution you've just seen is an open bath approach. Now, there's also other approaches. So enclosed chassis. You guys may be familiar with chassis that are completely sealed, that are filled up with liquids, that either allow liquid to flow through the chassis or keep liquid inside the chassis. That's something that we've defined as an enclosed chassis approach. Open bath approach doesn't describe the fact that the bath is actually open. It describes that the liquid is interfacing with air in some way. So there is surface tension between the dielectric liquid and air. And there might be some hybrid solutions. Some solutions that maybe open bath and fit inside a rack, for example, or anything else that might be coming up, that people might be inventing over the next few years. Things that we don't know about yet. But we need to give those type of solutions a place in the OCP ecosystem. And all these immersion styles have their own related characteristics that are relevant to be aware about. So this document is not only about applying the standards, it's also about education. It's about educating the industry on these type of technologies. And the cooling circuit that applies can also be radically different between these different technologies. Either it's direct to the chassis or with a CDU, a coolant distribution unit. Or maybe a solution is connected directly to any kind of infrastructure that is present inside a data center. So in order to allow these technologies into the OCP space, but also into data centers, we've defined a set of requirements that they need to comply with, as mentioned. And one of these requirements is certification. Now, globally, there are a lot of different types of certification. So instead of documenting them all, we've just referenced to a Wikipedia page which outlines those regulations. But these regulations, these certifications should be taken seriously because these involve legalities in many different areas. So in Europe, you can't even trade anything that's not marked as CE. In the United States, UL certifications are quite relevant. And we also require certain safety standards. And these things these are things that you might not be hearing from vendors themselves, because this is something that is, because it's a new technology, it can be scary for a lot of people to talk about safety precautions. But we are talking about very often industrial size systems that are heavy or that you need to be able to operate from an electrical perspective or even a mechanical perspective. And these solutions should be developed or must be developed in such a way that they can be operated safely. Whether it's for maintenance, for maintaining a server, or whether it's for installing or setting it up, these safety standards must be followed up on. And it doesn't stop with safety with human safety. It also includes liquid management procedures. The fact that you have to consider liquid as part of a holistic solution. Data centers are all about disaster scenarios. Every data center is built with disasters in mind. And this is a topic that has been avoided for a long time. Now it's time for this industry to get to a next maturity level. And that means that these things need to come out. We need to know what we're dealing with. And that means just being aware. And it's not rocket science, it's not scary, it's not dangerous. It's actually very easy. If anything, it will make your data center much more robust than before. But still, these are things that we need to be aware about. So, to differentiate between all these technologies, you can see a lot of different levels in engineering or in solutions, in complexity, and these all translate into a value of some kind, whether it's a value on the cost side, TCO, or whether it's a value on functionality, or safety, or resiliency. Now, in order to address and encapsulate these features, these values, we've defined some feature classifications. Now, the current classifications are standard, that's a minimum basic level. I'll get into the details of how that's done and what is required within those levels this afternoon. We have a classification for thermal optimization, which monitors, which allows you to optimize the water circuit, but also keep the thermodynamics stable inside an immersion environment. And high safety, which goes towards tier 3 and 4 environments, where high availability becomes an issue and a certain quality level of continuity is assured. And there's more classifications that will be defined. So this document allows the addition of more classifications. One of the classifications that was recently suggested by WeWin was serviceability, which is a great one. And these kind of topics we can encapsulate, or we can at least consider to encapsulate and define to make technologies comparable and to allow the industry to select the right technologies for the right part of their infrastructure. One other thing that we've discussed is that is also required is the fact that we have a completely different type of compute environment, different type of racks, which need to be managed. They need to be able to hook into any kind of data center infrastructure management. So we've defined a very basic standard for that, which is based on Redfish, because that's the standard within OCP. And that allows reporting features, that allows logging, that allows alarming or control set points. It allows anyone to start building upon the management system to increase functionality, to increase interoperability with existing OCP environments. Now, from that safety or standards from an engineering point of view or a safety point of view, there's also descriptions of technology that wildly differ. Now, we've made an attempt to get a grip on that as well, to allow somewhat standardization of everything that is involved with immersion technology. So we've outlined a description, a way of describing a technology which allows people to quickly understand what they're confronted with. And that includes the immersion solution style, which I've covered earlier. And again, this afternoon we'll go in the nice and gritty details of this. It goes into the solution type. It needs to define a liquid category, what type of liquids, and also which features a solution is compliant with. But here it becomes really interesting, because now we're getting into an area where you want to start comparing technologies. Now, one of the main arguments that we hear a lot, and actually we just heard it with Alibaba as well, we can do 100 kilowatts in a rack. That's great. How big is that rack on the floor? A normal rack, 600 by 1200 millimeters. We're basing, by the way, on SI units. That's the international system of units. That's what we use as a metric. So we're using meters. Apologies for everyone here that is unfamiliar with the SI system. But a rack that is on its back is bigger in size when you look at the footprint. So what does that density figure of 100 kilowatts in a rack actually mean? Well, this is where we have applied density figures. So there are three types of density figures. It's compute density, solution density, and solution footprint. Compute density would cover the actual rack. The surface, floor surface, and the density divided, and then you come up with a kilowatt per square meter. Solution density includes everything that is attached to the rack to make it functional. Let's say there's water piping, water interface, maybe a pump space, service area, electrical panel. That all has to be included. Solution footprint also includes the surface area that you need to maneuver around a solution to apply servicing, to extract service, to do what you need to do with an immersion system, with the IT that is inside. And still those figures are then fairly vague because, especially with immersion, the density is greatly influenced by the temperature of cooling. So a 100 kilowatt tank, if you apply 12-degree cooling to it, you can achieve much higher densities compared to 40 degrees Celsius cooling. But from a TCO perspective, the chiller unit that you don't have to buy for 40 degrees Celsius gives you an additional TCO benefit, whereas the density, the incredible density you can achieve with lower temperatures, gives you a density advantage. Now, and this is why these figures are important. If you're not looking for the crazy densities, but you just want to have the most efficient solution, then the higher temperatures are more relevant. Then it shouldn't be a question of which technology can achieve the highest density. It's about comparing the metrics to what you actually are looking for in a technology. Now, to make these figures comparable, we've defined a mandatory figure, which is the ASHRAE W3 solution footprint, which is the solution footprint figure based on 32 degrees Celsius cooling. It's an ASHRAE standard, and that's a level of cooling that we've determined that every liquid technology should be able to operate with. Now, there's a lot of other data that we want to make available which we want manufacturers and vendors to make available towards the market, and these are all related to efficiency figures, things that you might not be considering yet, simply because it's still a very new technology. But there is such a thing as thermal losses to air. If a system is losing, let's say, 10 or 15% of that thermal energy to the air environment, you still are going to need crack units, simply to cool down that thermal loss. These figures are becoming relevant. The chassis type, chassis size, compatibility of brands, these things are all going to factor in. Now, here's an interesting one. How many of you are actually familiar with dielectric liquids? Can you stick up your hands, please? Right. So you'll probably recognize these figures on the right side, 30 kilowatts per millimeter as 30 kilovolts per millimeter as a dielectric strength, 35 plus, 40 plus, 45 plus, 50 plus. Does anyone know where those figures come from? Anyone? These figures originate from the high voltage transformers, transformer oil. That was the only reference we had in the industry at some point in time. What does that do? 200,000 volts. That's what a high voltage transformer does. 200,000 volts. What are we talking about? 12-volt DC. That is perfectly fine to operate in air. Air has a dielectric strength of 3 kilovolts per millimeter. Now, we put this number in for a reason. At 3 kilovolts per millimeter, I am going to come clean with you guys. I don't know. And that's the problem. Nobody does. What is actually required for IT to operate in a dielectric liquid? What kind of dielectric strength is the actual minimum? Nobody's ever done the research. Nobody. People are claiming it has to be 50, it has to be 35. Nobody really knows. Nobody's ever been able to describe that. So if you look at this from a scientific perspective, and that's, I think, also the point, anything that insulates better than air should be able to do the job. So we've been erring on the safe side. I'm not saying that we should all try and come up with liquids that do 3 kilovolts. All I'm saying is this is an industry that is now starting to mature. This is the type of data that we're going to be working with. This is the stuff that we need to recognize when evaluating technologies. that current standards that we maintain may be excessive. Be open for new insights and new ideas. We're nearing the end, so another thing that we require from all the technologies is simple documentation. Every technology must be documented, as any industrial device or any complex system should, and also is. If you buy a server from Intel, you will have access to a manual. You will have access to, it will be certified. And you can find in the documentation how it's certified and which certifications it complies with. Just open any manual from Intel or from any other vendor. Liquid technologies are not different. These systems should have this documentation, and the good vendors do have that. MSDS, which is Material Safety Data Sheet, TDS stands for Technical Data Sheet, part of the chemical industry. Mind you, fluorocarbons and hydrocarbons, they're both chemicals. They're not scary at all. Trust me, I've been working with all these liquids. They're really benign, but they are chemicals. That means you need to have these type of documents in place. You need to think about liquid management and fire management procedures. Doesn't matter what type of liquid you have, it needs to be done. It just needs to be thought through. Maybe it's usually better to work with immersion. The fact that you have, even if you apply oil as a standard, it will actually reduce your risk of fire. So this afternoon at 3:30 we'll be going into a lot of details and a lot of examples of this, and I would really like to get everybody's feedback on that. It's going to be interactive. It's not going to be a monologue like I'm standing here now. It's going to be much more like a workshop, and we'd like to be able to discuss all these items and to get feedback on it, and also to clarify the intentions behind all these standards and all these metrics. The workstream has submitted this document, and this document will be maintained. We're looking at a refresh rate of every 6 months or so. In the meantime, we're going to be working on the next standards and guidelines, and that's going to be related to IT gear. Now, that will be less strict than this first foundation document. And that will be focused on design guidelines, how to design IT, how to design servers for liquid. And there will be many different angles for that, especially because of the liquid technologies, two-phase, single-phase, fluorocarbon, hydrocarbon. They will come up with completely different design requirements. Going into liquid compatibility, you just saw, for the people who were here during the Alibaba presentation, you saw that they also do the homework on material compatibility. That's something that has to be done. That's something that everybody needs to be familiar with, especially if you're designing it for immersion. Some materials you simply need to avoid. And that's stuff that we're going to discuss and document in this work stream. Thermodynamics, it's all part of it. We'll also be going into immersion systems. We'll be reviewing technologies that are entering the OCP space. That's all part of the immersion workstream. So this presentation will be available online. So for all of you who've been making pictures, feel free to download this from the website. This afternoon, there's a more extended presentation that I'll be using this afternoon that contains also samples of what these metrics look like. So anyone who is interested in immersion, because I see a lot of people nodding or listening, being interested, make sure to join the immersion workstream. This is the new industry. This is going to become the new standards. This is an exciting workstream. This is where the things are going to happen. We could use all the contributions, all the experience and all the knowledge from the whole community. So make sure to dial in, make sure to participate, and make sure to contribute so far this presentation. Any questions? It's almost like one of these workstream calls. Not all at the same time, please. Yes?
I know you're talking about standards, but I'm just curious what your thoughts are on what a future data center might look like. I mean, a tank doesn't make sense to have a built for a 1200 by 640 necessarily. So I'm wondering what, I'm trying to conceptualize in my head, what would that look like?
What, in my conception, a data center in the future looks like? Well, I can tell you honestly, that data center will not contain any cooling installations anymore. Any. In my opinion. That data center will contain a variety of liquid technologies that are connected together and that are generating heat to an extent that it's too valuable to throw away to the air. So by applying reuse, you don't need to cool it anymore. Then the reuse becomes the cooling infrastructure. There's utility companies around the world already gearing up to distribute heat, because heat is energy. So if you ask me, what does a future data center look like? Well, it's not there tomorrow. It's not, probably also not next year. A couple that I'm familiar with. But if you want to know more about this topic, Wim Butus is sitting right over there. He's got a workshop this afternoon. Can you remind me what time, Wim?
3 o'clock.
At 3 o'clock as well, so it's conflicting with with one of the ACS streams. It's actually before this, before the extended version of this, and Wim will go deeper into the matter of energy-producing data centers. But the white space will be a mix of different types of liquid technologies to facilitate different parts of the infrastructure, different types of infrastructure, high density, storage, pure compute, hypervisors, low density, everything. Anyone else? Okay, well, thank you very much for being here.